Hello everyone, I am Arvind Agrath and today I am here to explain my conceptualization topic of chapter 3, that is periodic analog signals. So let's start. First of all, types of periodic analog signals. So mainly there are two types of periodic analog signals. First one is simple or a sine wave which cannot be decomposed into a simpler signal, and second one is composite periodic analog signal which is made up of multiple sine waves. So now let's study about simple periodic analog signal or sine wave. So the sine wave is the most fundamental form of simple periodic analog signal, and it can be represented by three parameters, that is peak amplitude, frequency and phase. And here the example of sine wave is given as a simple periodic analog signal. So now first of all, peak amplitude. So it is the absolute value of its highest intensity proportional to energy it carries, and peak amplitude is measured in volts for electronic signals. So as you can see in figure A, the amplitude of the given signal is high, and in the figure B the amplitude of the given signal is low. So the maximum value of amplitude is known as peak amplitude. Now, period and frequency. So, the amount of time a signal need to complete a cycle is known as a period, and the number of period in 1 second are known as frequency. Period and frequency both are inversely proportional to each other. So, the relation is given by f is equal to 1 by t, or t is equal to 1 by f, and period is expressed in seconds and frequency is expressed in hertz. The value of the signal changes over a short time, then the frequency is high. And if the value of the signal does not changes for a short time or changes over a long span of time, then the frequency is low as it is inversely proportional. So in the given figure, you can see in the first figure, the signal is given with the frequency of 12 Hz. That means 12 periods in 1 second. The signal will cover 12 periods in 1 second. So the frequency is 12 Hz. And in second figure B, the signal is given with the frequency of 6 Hz. So 6 periods are covered in 1 second. Now the next one is phase. The term phase describes the position of the waveform relative to time 0. Phase is measured in degree or radians. So the 90-degree refers to shift 1/4 of the time period from 0, and 180-degree refers to shift 1/2 of the time period from 0. So as you can see in the first figure, the wave starts from 0 degrees. In second figure, you can see the 90 degrees, so the wave is shifted left side uh, in 1/4 of time period, and in third figure you can see the wave is shifted half of the time period left side. So that is signal advancing. So now the next topic is composite signal. The composite signal is a combination of simple sine waves with different frequency, amplitude and phases as per Fourier. A composite signal can be either periodic or non-periodic. If the composite signal is periodic, the decomposition gives a series of signal with discrete frequencies. If the composite signal is non-periodic, the decomposition gives a combination of sine wave with continuous frequencies. So periodic composite signal. So a signal of a series of simple sine waves with discrete frequency is known as periodic composite signal. So as you can see in the first figure, there is an example of composite periodic signal. The amplitude of sine wave with frequency f is almost the same as the peak amplitude of the composite signal. The amplitude of the sine wave with frequency 3f is one third of the first, and it is known as third harmonic. The amplitude of sine waves with frequency 9f is one ninth of the first, and it is the ninth harmonic of the frequency. So as you can see in the second figure A, there is a time domain decomposition of the composite signal as frequency the f, then 3f and 9f. And in second figure B, frequency domain decomposition of composite signal is given through peak amplitude of f, 3f and 9f. Now next is non-periodic composite signal. A non-periodic composite signal can be decomposed into a combination of an infinite number of simple sine waves with continuous frequencies. Uh, Continuous means the frequency that have real values. Signal does not repeat itself after fixed time period or are non-periodic. So as you can see in both the figure, you can see there is no repetition of the signal along time period. It is not repeating and it is irregular, so it is known as non-periodic. And most of the signals in real life are non-periodic signals, as for example we can take voice signal. So sometimes the frequency of voice is very high and sometimes it is low. Now bandwidth, the range of the frequency contained in the composite signal is its bandwidth. The bandwidth of the composite signal is different between the highest and the lowest frequency content in the signal. So, for example, here I have given one example that of a signal of having frequency of 500 Hz to 3000 Hz. Therefore, the bandwidth will be the difference between the lowest and the highest frequency. So, here it is 2500. The bandwidth of the non-periodic signal has the same range but the frequency are continuous. As you can see in figure A, the bandwidth is given of a periodic signal, and in figure B, the bandwidth of a non-periodic signal is given. And the calculation is also given that frequency starts from 1000 to 5000 Hz and the bandwidth will be 4000 Hz. And in second figure also bandwidth will be 4000 Hz. Thank you.